So, right now, as you're watching this explainer, you are completely submerged in an invisible ocean of waves. Seriously, think about it for a second. What unseen forces have the power to instantly connect your cell phone to someone halfway across the globe, yet also possess the incredible ability to see straight through human tissue to heal broken bones? Well, let's dive into this, because the answer is not only fascinating, it's absolutely fundamental to our modern lives.
Welcome to this explainer. Today, we are going to completely demystify the unseen forces that power our world. We're decoding the electromagnetic spectrum. And just to put things into perspective right out of the gate, the visible light that we actually see with our own eyes makes up less than a fraction of a percent of the entire spectrum. It's wild. So, we're going to break down the science of how these incredible waves travel, how we harness them, and what they actually mean for living things.
Here's a quick look at our roadmap for today. First, invisible waves. Second, mapping the spectrum. Third, global communication. Fourth, medical marvels. And finally, radiation risks.
All right, let's jump right into Section 1, the invisible waves around us. Before we go deeper, I want you to take a quick mental inventory using this TWLH framework. Ask yourself, what do you think you already know about electromagnetic waves, and what do you want to know? By the end of this explainer, we're going to lock in exactly what we learned today and exactly how we know it.
Moving right along to Section 2, Mapping the Spectrum.
Take a look at this chart. This is our ultimate roadmap. On the far left, you've got these sprawling, long radio waves at a frequency of 10 to the third. But as you travel to the right, moving past that tiny sliver of visible light you're using to watch this explainer right now, the energy compounds exponentially. It peaks all the way over on the far right with gamma rays at an absolutely incredible 10 to the 12th. It is all one continuous spectrum, but the properties of the waves change drastically as you move across it.
Now, the absolutely crucial point here is understanding the mathematical relationship between wavelength and frequency. I want you to think of it kind of like ocean waves. Long, rolling wavelengths have a low frequency. They're slower, but as those waves get tightly packed and shorter, they hit you faster, right? The frequency and the energy rapidly spike, and it's this simple math that dictates exactly why a radio wave is completely harmless to us, but an X-ray requires you to wear a heavy lead shield.
Which brings us to Section 3. Powering global communication. Looking back at the low-frequency side of our map, we see some truly incredible telecom applications. Radio waves efficiently broadcast our television and radio signals. They just wash right over us harmlessly while carrying immense amounts of data. But right next to them on the spectrum are microwaves. And no, they aren't just for heating up your leftovers. Engineers specifically rely on this exact frequency because it can literally pierce the Earth's atmosphere without scattering. They bounce off satellites orbiting thousands of miles above us just to deliver a GPS coordinate to your phone in a matter of milliseconds. How cool is that?
Next up, Section 4, Medical and Industrial Marvels.
Okay, so here is the dramatic pivot. This is where we have to distinguish between ionizing and non-ionizing radiation. Higher frequency waves, like those X-rays and gamma rays, become what we call ionizing. This means they carry so much energy that they can literally knock electrons right out of atoms. They have enough sheer power to alter living cells. And that is vastly different from the safe, non-ionizing radio waves and microwaves we rely on every day for our cell phones. But here's the fascinating paradox in all of this. The exact same cellular destroying energy that makes high-frequency radiation dangerous, it's exactly what oncologists weaponize to target and destroy cancerous tumors. X-rays pass right through soft tissue so doctors can scan for broken bones, and gamma rays are deliberately harnessed in targeted radiation therapy. We are literally wielding radiation to save lives.
And beyond the hospital walls, industry wields these waves like a superpower. Because X-rays and gamma rays can penetrate solid objects, they're used for non-destructive material inspections. I mean, imagine being able to peer deep inside a solid steel aircraft engine to find microscopic cracks without lifting a single wrench. It's a total game changer. Plus, the intense cellular destroying power of gamma rays allows for the absolute eradication of pathogens. It instantly sterilizes critical medical and surgical tools.
And finally, Section 5, weighing the radiation risks. So, because ionizing radiation alters human cells and damages DNA, we absolutely cannot ignore the biological stakes here. Scientists, engineers, and doctors have to rigorously weigh the incredible life-saving benefits of diagnostic imaging and cancer treatments against the potential long-term risks to living tissue. It is a very delicate, highly calculated balance. We are essentially taking a fundamentally destructive force and using it for a constructive, healing purpose.
To kind of synthesize everything we've talked about today, let's use the NICE framework. Just reflect for a second. What nuance do you need to work on or grasp a bit better? What was insightful about how these waves actually shape our reality? What do you find challenging about the biological risks involved? And finally, what space does this open up for you to explore further?
From the radio waves streaming data straight to your pocket, to the gamma rays fighting cancer cells in hospitals, you are constantly navigating an unseen universe. So the next time you make a phone call or see an X-ray, ask yourself, what other invisible forces are shaping your reality right now? Thanks so much for joining me on this explainer, and keep questioning the invisible.